Hi everyone, welcome back to Cody's Lab. So I was recently challenged to extract iodine from iodized salt. There's not a lot of iodine in here since iodine is a micronutrient that you don't need in very large amounts, but it should be rather doable. One thing I'm going to note before I start is this is not going to be a very practical way of getting iodine. It would be far cheaper and easier just to buy iodine or even sodium iodide. Let's have a look at the label real quick. Let's zoom in here so it has salt. Obviously, this is a can of salt. Sodium siluminate, so that's your anti-caking agent. Dextrose. Oh, a little bit of sugar in there. That's interesting. Potassium iodide, that's the stuff we want to get out. And sodium bicarbonate. Alright, so sometimes they have a sodium iodate in the salt for the iodine source. That would complicate things. I could still do it. I think I would just bake it in an oven at 500 degrees centigrade to decompose the iodate into iodide. You know, this is kind of like math. You know, convert into a form that you've already solved, or that you know how to solve, right? There is a lot of sodium chloride here, and not very much sodium iodide. In fact, it says on here that it's got 67 micrograms per serving, and a serving is a quarter teaspoon. So let me actually figure out how much that is real quick. Okay, so that's approximately 32 milligrams of iodine for each of these cans. And considering that that is 737 grams of salt, yeah, the percentage is very low. Should still be extractable though. Alright, so first thing we gotta do is open up one of these cans. I'm gonna pour it over into this beaker here. Okay, now that that's done, I've got a bunch of sodium chloride crystals with a little bit of potassium iodide and some other stuff. Let's actually zoom in on this here. I'm pretty sure that the potassium iodide is not locked inside of the salt crystals. I'm pretty sure they just add it to it after the fact. And since they are crystals, I would expect that even as it crystallizes, the iodide would be forced out. Fractional crystallization would exclude the large atoms like that. So it's probably just added in after, so they just kind of sprinkled it in and then mixed it all up. Which means I don't have to dissolve the entire amount, I can just wash it off. Now, you could do that with water, but that would be really hard because then you just end up with a solution with a bunch of salt in it. So, I'm going to use something that does not dissolve salt, but will dissolve the iodide. Sodium chloride, almost completely insoluble. Only maybe a few milligrams will dissolve in a liter of acetone. Iodide, however, you'll get several grams. So, this should be able to effectively wash the iodine off of the salt. So let me just tip some in here. So I'll just stir this around, make sure the acetone contacts all of the salt grains, and therefore dissolve away all of the iodide. Might have to add more. One thing I'd like to mention real quick is that I'm working at very low temperatures. If you're working during the summer and the acetone had a higher vapor pressure, you'd want to do this in a fume hood, which I will be getting soon, by the way. Okay, now that I'm pretty sure that all of the iodide has been dissolved, I'm going to take the acetone and pour it through a little vacuum filter into a 1-liter flask. This is to remove the anti-caking agent. Okay, so after washing several times and using, almost filling my 1-liter flask, think I've got most of the iodide out of here. So if you haven't already guessed, the reason that I'm doing this inside of my distillation apparatus is I'm going to distill off the acetone and reuse it. Well, here's the first batch of iodine depleted salt. Once this dries, it should be safe to eat again. Although, without the iodine, what's the point, right? Alright, seems to be working well enough. I am realizing this is going to take a long time to do all 6 of those cans though. Maybe I'll just stop after a couple of them. And that's just about it. I've transferred all of the acetone over. And hopefully all my iodine has stayed. Let's have a look at that. Is that... got some salt. Oh yeah, there's a little bit of crusty white stuff in there, as I'd expect. Not very much though. So good. Well, let's run this through some more salt then. It is boiled dry. There's my acetone. I've just done 3 of these. I think I'm going to stop there because this is just taking way too long. So now that I've got my hopefully concentrated iodine and all of the acetone has been evaporated off, I'm going to add some water to finish dissolving, to redissolve it so that I can transfer it out of the vessel into a little beaker here. Excellent. Let's rinse it a couple of times. So now what I've got is a stir bar mixed with some sodium iodide, sodium chloride because it's not completely insoluble, and of course a little bit of slightly burnt dextrose. So it's a little bit sugar water probably. Okay, the mixture's a little cloudy. It's probably not anything to worry about. So now I'm going to add a little bit of a silver nitrate solution. This is to precipitate all of the halides out of solution as silver chloride and silver iodide. Silver iodide is a nice yellow color, and you can see that a yellow precipitate has formed. Excellent. It has worked. Let me put this into a slightly bigger vessel here. Yeah, that's definitely iodine. You can see the silver iodide's already started to darken in the little bit of light that I got here. So, let's get the iodide separated from the chloride, shall we? This is a little bit of ammonium hydroxide, and this will cause the silver chloride to become soluble, but the silver iodide to not be soluble. So this will dissolve all of the chloride, leaving just the iodide. The sugar and the chlorides should all be dissolved. So let's just pour this off, and I should be left with silver iodide. Should be relatively pure too. It will darken over time as the light exposure causes it to turn into silver metal. But that shouldn't cause too much trouble for me. Now I know you all aren't going to be satisfied until I've got this turned into elemental iodine. So I'm going to wash this with some distilled water a few times to remove excess silver and of course the other salts. The ammonia would also cause trouble, so let's get rid of it. I will lose some iodine doing this, but I'll save the wash water. Now that I've got it washed pretty well, I'm going to convert the silver iodide back into sodium iodide by adding a little bit of sodium hydroxide here. The silver will form silver oxide, and of course I'll end up with a little bit of sodium iodide. So now I should have a solution of sodium iodide in water. So I'm going to decant this into a test tube. So now I'm going to acidify the solution with a little bit of hydrochloric acid. Okay. And now I'm going to add in some hydrogen peroxide. There we go. Elemental iodine. So there it is. It's probably not super pure, and I'll tell you right now, my recovery wasn't great. There should have been about 100 milligrams in that sample of salt I did, and it looks to me like I probably recovered between 5 and 10 milligrams of iodine. But I was able to do it. Hope you enjoyed. I'll see you next time. Let's take some of the silver iodide that I poured off, and let's not add the sodium hydroxide to it. Let's just jump straight to sulfuric acid. Alright, I don't see anything happening there. Well, let's turn back to yellow. No iodine produced, though. Very interesting.